Hi everyone, and welcome to another video of the SAFI webinar series. In this video, we are going to have an overview of built-up sections. Built-up sections are built from other existing sections. The properties of built-up sections are computed based on the properties and dimensions of the source sections and assembly schema. Unless noted otherwise, if the source sections defining the built-up sections are modified by the user, the properties of the built-up sections should be recalculated accordingly by editing the section, clicking on the Recalculate Properties button. It is possible to display the finite element mesh used to calculate the properties of the built-up section by clicking on the button Mesh Preview. Another way to create built-up sections is to use the SAFI Section Builder, which allows the user to create custom built-up sections made of a combination of other sections and/or thin sheets. Each component may be defined as a continuous component or a lacing component. Lacing components are effective only in shear and torsion properties. The section defined in the SAFI Section Builder can be composed of a single component, for example, cold form sections. To verify built-up sections, the user needs to specify the class of the section in compression, positive and negative bending, as well as the weak axis bending. In the case of slender sections, the appropriate effective property must be specified. It is possible to obtain the class of the components of the built-up section by clicking on this button. In this case, these properties will not consider any attachments between the components of the built-up section. Let's start our demo. We can create a built-up section clicking on the menu Tables, selecting Sections, then we select the Built-up Sections command. It is also possible to use the Sections toolbar. To display the Sections toolbar, we do a right-click on the mouse and we select Sections from this list. On the Sections toolbar, we can create a built-up section by clicking on this button. To add a built-up section, we need to click on Add a New Tab button. From this list, the user needs to specify an assembly schema. For example, I-shape with a channel cap. For each assembly schema, the user needs to assign the source sections. So, in this case, the main section, IM, which is displayed in red color in this image, must be an I-shaped section. We can select the section from this list if it's already added to the model. If it's not, we can create it by clicking on the arrow button. We select standard sections or non-standard sections. So in this example, we're going to use standard sections. Then we select a library, the section type W, and the section name. We click Add and then Close. Now this section is available from this list. The second section is a cap section CC, which is displayed in yellow color in this image. We add it in a similar manner. We then click Add, then Close. Now this is available from this list. After adding all the source sections, we can see a preview of the shape of the section. The next step is to calculate the properties of the built-up section. We do that by clicking on the button Recalculate Properties. When the calculation of the properties is done, we can see the right-hand side of this dialog box and the properties of the built-up section. We can rename the built-up section by clicking on the Name tab or by using the Rename Current tab. Now we click OK to validate. Let's create a member. To assign a built-up section to a member, we assign it as any other section. So, we edit the attributes of the member, and we select the built-up section from this menu, and we click OK to validate. Now we can see a preview of the built-up section assigned to this member. To preview the mesh used to calculate the properties of the built-up section, we click on the button Mesh Preview. To verify the built-up section, we need to specify the classification of the section. So, we need to specify the class for compression, for positive and negative bending, and the bending on the weak axes. We can also specify the slenderness of the web, which has an influence on the shear resistance. If we have a slender class, we need to specify the effective properties of the slender section. For a slender section in compression, we need to specify the effective area in compression. Let's add some support to this beam and add a uniform load on the beam. Then we can run the analysis. In this case, we activate the verification for steel according to the Canadian code S16. If we display the steel verification results, we can see the results for different limit states including compression, tension, bending, combined bending, and also other limit states including shear, torsion, and warping. It is also possible to create built-up sections using the SAFI section builder. From the built-up section dialog box, when we click on Add a new tab, the last option in this menu is the SAFI section builder command. In this dialog box, the user can create built-up sections manually by using existing standard and non-standard sections of SAFI. For example, we can select the W section we used in this example and we can place it on this grid. We can also insert a polyline using this command. We select the thickness of the polyline and the corner radius. Then we click OK. After that, we select two intersections of the grid lines. The grid can be edited using the command define grid. So, by default, the spacing between the main grid lines is 100 mm and the number of subspacing is equal to 5. The user can change that if needed. If we want a number of subspacing equal to 10, we can change it from here. In this case, the distance between the two grid lines is equal to 10 mm. It is possible to insert a polygon. We need to specify the corner radius. Then, we draw on the grid the polygon. I'm going to draw a square here. If we want to add an opening inside the polygon, we can use this command insert opening. First, we click on the polygon, then we draw the opening. If we want to delete a component of the built-up section, we can use this button, Erase Component. We simply click on the component that we want to delete, then it will be deleted. To select any components, we use this button, Select Components, or the shortcut S, which is the default shortcut for selection in the program. For each component, we can do a series of operations including copy, move, rotate, flip horizontally, and flip vertically. For example, if I want to create a copy of this plate, first I select the plate, then I click on this button Copy, and then I select where I want to paste it. Now we can see that this plate is not positioned in the right position. We can move it using this button, Move Selected Components. First, we select the component, then we use the Move command. We select the point where we want to move it, and we click on the destination position. It is also possible to modify the component properties. If we click on the button Modify Components, we can click on any component to edit the components. In this case, the component is a polyline. The user can edit the thickness, the category, and all other properties of this polyline, including the positions as well, and the rounding. If we edit the components of a section, The user has the possibility to change the section, change the position of the section, the rotation angle, or flip the section vertically or horizontal. The user can edit the vertex by clicking on the vertex. Then, we change the position and the interior rounding. To display the mesh, we can click on this button and then we can see the mesh that the program will use to calculate the properties of the built-up section. We can also view the properties and stresses by clicking on this button. So, we can see the properties of the built-up section on the left, and we can display the stresses by specifying the applied forces. For example, if we specify a bending moment here, we can see a display of stresses in this dialog box. We can then select what type of results we want to display. We can display axial stresses, shear stresses, and von Mises stresses. For each of the stress categories, we can select a subcategory. In this case, for example, for axial stresses, we can select the sigma x from fx. The last step is to save the section. We can edit the name here, and we click OK. After that, this section will be added as a regular built-up section, and we can use it in a similar way. That's it for this video. Thank you for watching, and catch you in another one of our webinar series videos.